everyone, Mr. Mueller here, and hey, we are on our last target for this course. So if you've been keeping up, everything's been going pretty well, give yourself a pat on the back. This will be your last target of this official school year, okay? And what nice thing is, it's very similar to Target 11.1 where we tested hypotheses on population means. Now we're going to test hypotheses on population proportions like Roe. And you're going to perform a hypothesis test using sample data or summary statistics and properly state the conclusion of the hypothesis test. So most everything you did, if you understood Target 11.2 about hypothesis testing, it's almost basically the same, just a couple exceptions. So we're going to start off with a little example here. Let's say, for instance, a friend of yours wants to play a simple coin flipping game. If the coin comes up heads, you win. If the coin comes up tails, your friend wins. Now, suppose the outcome of 5 plays of this game is tail, 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 tail. In other words, 5 tails. Is your friend cheating? Well, ladies and gentlemen, at the heart of this problem is why we do hypothesis testing. Because the probability of getting 5 tails, ladies and gentlemen, is just 1/2 times itself, because it's probably getting tails, so the first flip is 1/2, and then 1/2 on the second, 1/2 on the third, 1/2 on the fourth, and 1/2 on the fifth. So really it's 1/2 to the 5th power, and you get 0.03125, which basically says, ladies and gentlemen, that if you were to do this experiment 100 times, approximately 3 out of every 100 times, you should get 5 tails in a row. Now, this just shows that it's possible to get 5 tails in a row, but it's not likely. So from this, we can draw 2 conclusions. Either your friend is not cheating, in other words, it's a fair coin, 50-50 coin, and they happen to just be lucky, okay? Or the other option is your friend is not using a fair coin, in other words, a coin where tails shows up a little bit more than heads. So how do we know which is it? Is he lucky or is he cheating? I should say he or she. That's the question at the heart of hypothesis testing. Is this value right here, did it occur out of just chance fluctuations in your sample? Because you could get every 3 out of 100, or is it due to some other circumstances? Is that strong enough to say that maybe the coin wasn't fair? So, and we'll probably test this later on. Matter of fact, we may even make this one of your practice problems. So the same, I believe it's 8 steps you're going to follow, ladies and gentlemen. The only thing is that we are talking about a different population parameter of interest. We're going to be talking about Rho, which is a population proportion. And by the way, remember, population proportions are based off of categorical data, okay? They're not based off quantitative data, they're based off counts or categorical data. So remember that, especially when we do our first example. We're still going to state a null and alternative hypothesis, this time involving Rho. We're going to identify the significance level, just like we did before. Now, this is going to be different because we're not talking about a t-distribution like we did with population means. We're talking about a standard normal z-distribution. And we'll talk about those requirements here in a little bit. You can draw a sketch if you need to. We're going to calculate the value of the test statistic, which is going to be a little bit different because it's going to involve, again, a standard normal z-score and not a t-score. And then we're going to use that to find a p-value, compare it to alpha, and then state the conclusion. So a lot of these steps are the same as before, it's just a couple of them are a little bit different. Okay? Now, the requirements for performing a hypothesis test about a population proportion, because again, we're dealing with categorical counts that we're going to look at on a z-distribution, and that is what we call a standard normal distribution. It's bell-shaped, unimodal, and symmetric, okay? We've talked about those. We talked about z-scores back with confidence intervals for the population proportion Rho. We've also talked to them back. We did z-scores back in the first semester. So these 3 conditions are the exact, they should say exact, but very much similar to ladies and gentlemen, what we did back with confidence intervals for rho. The sample has to be a simple random sample. The sample has to be less than 10% of population, which basically means you're going to take 10 times your sample size, and that has to be less than the size of the population. And you remember, population size can be abbreviated with a capital N, sample size is lowercase n. And then both n times the hypothesized proportion has to be greater than 10, and n times 1 minus the hypothesized proportion. Now, where do we get these values from right here? What does this mean, p sub 0 or p sub naught? Well, we're assuming when we set up our null hypothesis that the null hypothesis is true. So, in other words, when you set up your null hypothesis, and I'll talk about this later, we're going to assume that that's going to be some value, equal to some value between 0 and 1, like let's say 0.40, okay? Well, if we're assuming that to be true, that's what we're going to use in our setting up our null hypothesis, also when we calculate our test statistic. A common mistake is people want to use p hat for these two values. Do not use p hat. We're comparing our test, our sample data, to what we hypothesize the population proportion to be. So again, p sub 0 means get that value from the null hypothesis, okay? And that's really a common error people make, and we'll try to make sure we